I mean, you'll go to a text and they'll give you a number for speed of light, but we can only measure the speed of light as a two-way trip, there and back. We've never figured out as a society yet to measure a one-way path of light. So we don't really know what the speed of light is.
And there's a life for this instrument.
What's that?
A life, then it will expire, because the laser resource, maybe it will be less or something.
Yes, it will diffuse over distance. So it'll start spreading out and it gets to the point we can't read it. But we can shoot a long ways. I mean, I've shot EDM shots with a survey instrument over 20 plus miles, where I can't even see the instrument I'm shooting at. 20 miles is a long ways to shoot a laser light and get it back.
Wait, get it back?
Yeah, it's got to hit the target and come back to me to tell me the distance.
How long does it take? Really?
Oh yeah, you're talking light.
Wow.
Okay, but for example, the instrument works with a battery? Or how it works? How is general working? I mean, what power is
We have a device that shoots a laser. It goes and it hits a mirror. Then it hits the mirror and bounces back to us, and then we record it, the time, the difference.
Okay, it works with a battery? With the
Yes.
device?
Mhm.
So if the battery's power gets less, it doesn't affect your reading?
The battery powers the device that's running all this stuff. Yeah. You'll see it. We're going to pull it out. It's a piece of survey equipment. Okay, it's capable of generating the light and then recording when it comes back to you. Yes, what?
The stadium method, I mean, it didn't really tell me. It says it's a rapid, efficient method of measuring distances, not acting for height or surveys, but what is it? I mean, didn't really.
I'll teach you how to do the stadium method. It's really pretty cool. What we do is when we look through a survey instrument, and the one you looked through had stadia in it, you saw a crosshair like here, where that's the center. And what you're going to look for is stadia will have it'll have a couple lines where these two lines right here are stadia lines. It's meant to be used with a Philadelphia rod. At 100 feet, you will see 1 foot in between those two lines. Okay, so if I'm looking at a Philadelphia rod here, let me use a different color. So here's my Philadelphia rod sitting here. And I see my little square right here, and it says 4 foot 0 inches. And then right here, on that same Philadelphia rod, it says 5 foot 0 inches. So I have 1 foot. That means that the person holding the Philadelphia rod is exactly 100 feet away from the person. Now if I come through and this top one says 4 foot, or 4, it's actually all digital, right? So it's 4.0 feet, 4.5 feet. The person holding the rod's 50 feet away from me. So it's a proportional method used with optics to record distances. It's pretty cool, actually. I didn't cover this when we were in architectural, but remember you were all pacing in between your points? We could have just walked you out there and then just looked at that thing and read that distance and said, oh, they're this far away from us.
This is new level, yes?
Yeah, this is off any scope that has stadia marks in the scope. Not all of them do. Okay. Any others? Keep in mind, stadia is not very accurate. Plus or minus a couple feet. Because your eyes are all different, right? Further you get out there, you have a harder time reading this, exactly where you're at on that Philadelphia rod.
Are you looking at me? No,
I'm looking at myself.
Of course.
You know, when we were surveying this stuff, you had to know what your survey was doing. When we were like monitoring dams, one time I had one firm here monitoring a dam that's right above the Salmon River. And we had a bunch of cyanide and lead and mercury in this water. We didn't want that dam to fail. So we put a bunch of mirrors on it, and we surveyed it every day, twice a day, to make sure it wasn't moving. Because if it starts to move, we got to get in there and mitigate it. That would be catastrophic. It would have probably bankrupted the company. We found that we had to have the same person survey, because we could see error based on two different people surveyed, because their eyes were different. We had to survey the exact same time of day, because we had atmospheric differences that happened. We had to survey at the exact same temperature or do a temperature conversion on our survey, because we would see all of that. We would also have to take into account that due to temperature, the fluctuation of the steel in the stands. Because we were monitoring this thing so close, all our alarms would go off with 1/1000th of a foot of movement, and the sun would hit a metal stand, and it would expand the stand and set all our alarms off. Okay, so we had all of this stuff that we had to take into account. Now that's very exact surveying, hard to achieve. And we had to put all these protocols in place to get that accurate.
And that was all hand done, you didn't have all these.
No, we used a robotic total station, most accurate method we still have to this day. Yeah, that one survey instrument cost $250,000. And it was actually about a $3 million system when it was all set, because we had to have it in a shack that was heated, had power. We had an antenna that shot all the data to our office in another town. Yeah, it was,
Where was that? Was that here in Idaho?
yeah, this was up in Stanley Basin.
Which year?
Hmm?
Which year?
This would have been 1998, 7, somewhere right in there. Yeah. Technology's gone through. By the way, here's a piece of trivia for you. Who designed the first GPS surveying system in Idaho?
You.
I did.
Oh, hey, Hey.
And I did the second one in Nevada.
Wow.
Yeah, that's when all that
Impressive.
technology was coming in. Yeah.
That deserves an extra credit point.
Okay, good guess.
Okay.
All right, so that's kind of it on the map. The point being, you can gather a lot of data out there on a project before you ever get started on it. Do a little research. Don't just have somebody come in and say, oh, we're doing this project. Let me grab my notebook, let's go to the site. Generally, you're better off doing some homework first, then go to the site, because you're already going to have an idea of the conditions, where it's at, have some information about the site, you'll know what to look for. Okay. You will use these maps ongoing through a project also. Okay. So, your major map types: geographic, XY, no elevation. Topo, geographic map with elevation. Then we have different scales of them, where we have state maps, county maps, cadastral or plat maps, all the way down to a single one, which we are going to go into here, called a site plan or a plot map, right, of one individual piece of property. You can get some specialty maps, like geologic maps, things of that nature, to also aid you in some of the conditions that are going on. All right, that's all I had for today. The rest of the day is yours to work on your architectural project. Keep in mind, on Monday, we will start a drawing project for civil. Okay, we're going to do a cadastral map. Any questions for me? If I do call for your vocab, I will call for it on Monday. So if you haven't done it yet, you might want to think about that. Thanks for your time. The rest of the day is yours.